test summarizes how to name ionic compounds and write formulas for ionic compounds when you know the name. When naming ionic compounds, first you name the cation first, which is the positive ion, then the anion, which is the negative ion. The cation takes the name of the metal from which it is derived, because remember an ionic compound is mostly a metal plus a nonmetal, and the negative anion has the suffix IgE, or it is a polyatomic. So when a metal forms more than one ion, like a transition metal, iron forms +2 or +3, you always include a Roman numeral in the parentheses in the middle of the compound, right after the name of the cation. So, if you're naming an anion, that's a metal, it's the name of the metal. So Na plus is sodium ion, and Na is +1 because sodium is in the first group on the periodic table. Calcium is +2 because it's in the second group on the periodic table. So to form a perfect octet, calcium has to lose 2 electrons. So this is called the calcium ion. Aluminum is +3 because it is in the third group on the periodic table and would therefore have to lose 3 electrons to form a perfect octet. So it is called an aluminum ion. If an element forms more than one possible ion, then you have to indicate the charge in parentheses after the name. For example, iron 2, iron 3, or copper 1. And when you name ionic compounds, if the negative half is a single element, then you simply take the name of the element, this is hydrogen, take off the end of it and put on IDE. Fluorine becomes fluoride, chlorine, chloride, bromine, bromide, etc. And if it's a polyatomic ion, it's a little bit more complex, and there are rules to explain how we name ates and ites and other compounds at the end. And hydrogen carbonate means there's a hydrogen in the middle. Bicarbonate is an older term for hydrogen carbonate. So you may still see that in some references. So if we're going to name an ionic compound, we start with the cation name followed by the anion name. So in this case, it would start with calcium chloride. We do not need to include a Roman numeral because calcium is in the second group and will therefore always form a +2 ion, which is combined with chloride as a 2. You'll notice that there's no way to tell by looking at the name that it has 2, unlike covalent, which would be called dichloride. The second one is iron chlorate. Iron perchlorate. Perchlorate is the name of the polyatomic ion ClO4. And the 3 indicates that this is an iron +3 ion. Iron 2 bromide. Sodium hydrogen carbonate. And then this is an unusual one because it starts with a polyatomic ion, ammonium sulfate. So this has 2 polyatomic ions. Now if we want to go the other way from the name to the compound, this is sodium carbonate. We write the name of the cation first. Sodium is in the first group, so it's a +1. Carbonate is CO3 minus 2. So in order to balance it, what we do is there's only one of these. So in order to balance a -2 charge, we're going to have to include 2 of them. So we have N CO3. So let's check our charge balance and see if that works. There's 2 sodiums for a +1 charge each, and there's 1 CO3, but it has a -2 charge. So we end up with +2 minus a -2 plus a -2, which gives us a total charge of 0, which means we have a neutral compound, sodium carbonate. And that is how you write and balance formulas for ionic compounds. Let me give you one more example. Iron 3 sulfate. So iron +3 is the cation, and sulfate, SO4 -2, is the anion. And when we balance it, we'll need 2 irons to balance SO4. SO4 stays all together, so we put it in parentheses, and we'll give it a 3, and you'll notice that the 3 gets copied here, and the 2 gets copied here. So let me do my charge balance. 2 irons at +3 each give me a total charge of +6, and 3 sulfates at -2 each give me a total charge of -6. So +6 minus 6 equals 0, and I have a neutral compound.